Hello, hello. Welcome to another episode, or should I say a new episode of our recently rebranded channel, High Output AI. I'm Tom White, one of the co-founders of Maxwell Plus, and I got my co-founder here and dear friend, Elliot. How you doing, mate?
Cute. I'm doing well, mate. Yes, as Tom said, Elliot here, coming in from not so sunny Brisbane. It's been raining a little bit, but always good to be here. New camera setup, new branding, new everything. We're taking this to the next level. It's fun.
Did you get a new haircut?
I didn't get a new haircut. I mean, this is not top quality AI content, but I was actually thinking of getting a buzz cut, just getting real short hair. So, look out for that in an upcoming episode.
So why the rebranding? Elliot and I have been working on this for, what are we up to now? This is episode
14.
This is 14 weeks, more than a quarter, more than 25% of a year, more than, no, I can't do that math, 3% of my life. No, 1% of my life. So,
A while.
One. So why are we doing this? We've been doing a lot of topics for the last couple of weeks. We've done everything from horses roaming the globe and destroying things through to a lot of stuff on AI. And we realized, one, we naturally default to all of the topics around technology and AI. And two, our lovely, lovely listeners love to hear more about AI. And so with my background in management consulting and Elliot's background in AI development, and then where we cross over into the tech space as co-founders, we wondered what could we do to help people in this space. And so what we're trying to do here is we're trying to combine the worlds of problem solving and AI, see how those collide, and to help everyone out there who's working on AI projects to get the most out of their work. That's what you agree with,
Exactly.
right, Elliot?
100%. I mean, there will still be just as much nonsense and talking shit and everything else you've come to love, but we figured, look, that's the niche we know best. You'll have to give us poetic license to some weeks talk about horses, but I would expect almost all the content from now on to be about problem solving, AI, and getting beyond the basics, I think, in both of those fields. As we've spent a lot of time in this space, and we'd love to share what we've learned and help other people level up, and whether that's to get promotions or start businesses or whatever else. So, just get an interest in this space. That's what we're all about.
Yeah, so if you're listening to this and you're wondering whether you should keep listening to this, the way we feel about this is that if you already know your way around TensorFlow, if you already know your way around a computer and the AI world, don't listen to this to figure out what the function you should be using is, but listen to this to go up a level, to start a bit more of first principles, to understand how to actually get your AI out in the world, how to ask better questions of your AI models, and also importantly, how to get them used, how to get them out there and doing things. So today,
Exactamundo.
so preamble over, let's get into it and straight to the important questions. Elliot, tell us about the new camera setup and what are you drinking?
So my new camera setup, inspired by good old YouTuber Ali Abdaal, is just put my camera way over the other side of the room so you can see my desk, get a bit of a wider view of me. I can now also have the iPad with the show notes. Our imaginary producer, Jimmy Bob, has been replaced by an iPad. It just seems a little bit more fun, a little bit more relaxed. If I do keep looking over here, if you're not watching this on video, if you're getting the audio version, none of this means anything, but this is where my screen is, so forgive me, I'm still learning. And in terms of what I'm drinking, it was slim pickings out of the fridge today, but I had this Brookvale Union alcoholic ginger beer. It's also a Wednesday, so I didn't want to go too hard, so that's what I've got. What about you, Tom?
Well,
You also have a new camera setup.
I do have a new camera setup and basically just done the same thing of push it further away. There is just chaos in this room outside of the screen, but because I'm currently in the process of moving out, so my background will change. I'm also going on a bit of a holiday as well, and I'm taking all the gear with me, so there's going to be some wild and interesting backgrounds coming up in the future, and probably some dodgy internet connections, which will be fun to record with. But
Oh, good.
We'll
I
get
mean,
through
where
it.
are you going to be in about 6 weeks? Because that'll be our next live episode. We're going to be doing that from the beach or a yacht or something.
Oh, hang on. We're going to go on our holiday in about 5 or 6 weeks together.
Oh, shit.
Holy crap.
Wow. That could be fun.
Oh, okay.
All right.
Well, now we need to
Plan-
do that.
Plans pending.
Flights
Could be a special episode. All right. Good. And what are you drinking? You got your quaff?
No, I'm actually on the oolong tea this morning. The coffee is arriving in the post sometime this morning. So.
Ooh. Very nice.
Yeah. Just a nice little gentle brew to start the day.
Very good. Very good. We got a few topics today. Who is going first?
It's me this week.
Yeah, good. Well, dive into it.
So this week I'm going to be talking about Steve Jobs' speech to the Academy of Achievement. Don't know what the Academy of Achievement is, but he did a speech to them. It sounds important. And it was from June 1982, and it's a pretty playful speech. It's kind of I don't really know what the purpose was. It wasn't a very clear talk, but it was slight lambasting the Academy, slight life advice, and slight call to action on the planet. But there was one little section in it that just really grabbed my attention. And it was when Steve Jobs defined what he considered intelligence. And I'll play the clip now for you.
Magical clip insertion here.
Do.
Wow, what a clip.
So, big picture, 10,000 foot view, strategic thinking. This idea of zooming out have called all of those different things. And I just find it a really interesting, a really interesting trick when it comes to problem solving, and a really amazing skill to be able to develop, especially when you're deep down in the weeds of solving an incredibly difficult problem. And so what I want to talk about today was three things. One was, what is zooming out? What is this idea of big picture thinking? Two, how does it actually help with intelligence or solving problems? And then three, what would it mean for you if you're listening to this? What are the practicalities of zooming out? So
Cool.
I jumped into it, and zooming out, big picture thinking, 10,000 foot view, also called strategic thinking. Really what it just means is a change in perspective on the problem or the information or the data that you're looking at that moment. It's meant to signify moving away from the details and into something that's a bit broader and a bit higher level or a bit more fundamental. And one thing I realized as I was preparing for this show is that it's really, really hard to describe this skill without using spatial language, moving away or zooming out. It's really hard to describe this without doing that. But I think what it really means is it is just simply changing the perspective of the problem to consider on the spectrum that you're considering, to consider more of it rather than the finer detail of it. That would be zooming out to me.
Let's get pragmatic. I reckon we've probably heard this a billion times, rephrased a billion ways, like forest for the trees and all that sort of stuff.
Yeah.
But can you think of an example, even if it's a really trivial one, of when people aren't doing this and then how they could have zoomed out and why that helped?
Yeah, I think a really clear one and personal one, and one that probably everyone has been through, is thinking about your career goals, right?
Mm-hmm.
If your career goals in 10 years' time is to be sitting on a beach drinking, being retired, drinking ginger beer sours or whatever weird drink you're drinking, but your monthly goal and your yearly goal and your 3-yearly goals are all about grinding the corporate grind and not exactly saving money or not exactly putting yourself in a position to make a boatload of money, which means you can sit on the beach, then you've probably failed to zoom out to the 10-year horizon, right? and consider what you want to do overall. That's
a good one.
One off the top of my head.
Yeah, I was listening to one of the latest episodes of Cal Newport's podcast, and he was weirdly talking about exactly that. He's got this term, lifestyle-centric career planning, which is pretty much exactly that scenario. It's, are you right now setting yourself up for what you want your lifestyle to be? And he sort of notes that a lot of people aren't. They're sort of stuck in the right now. They'll optimize for their next promotion or, their next holiday. But until, as you say, you zoom out and take that bigger view, you may just be, doing these micro optimizations where you got to do the bigger thing.
Yeah. So, and that's one of the examples that I gave of this, is what you just said there. Is mathematically, I think it's the difference. Zooming out is considering global optimization versus local optimization. I think that's probably the best theoretical example that I could come up with. Another one that I thought of is changing the population or the cohort size as well. For example, you would make a different decision about the individual versus at the population level in a healthcare system.
Yeah, that's very true. That's a good one, actually. Because, and there are a lot of dynamics and factors and stuff that just don't even show up until you start looking at that level.
So I think that if I could do a pithy definition of zooming out, it is a change in perspective away from the detail to the whole.
Yeah, cool.
So I think the other thing that will come alongside this as well is that you generally, even though you're including more, you will drift away from complexity and you will go towards a more simple communication of whatever you're doing. And the reason is if you think about, let's take the iPhone, for example. If you wanted to explain to me how the processor in the iPhone works, you would need to go into a lot of detail and a lot of complexity, and I would need to be able to understand that to understand how the processor works. But then if we zoom out and we go to the higher level and to explain like what the iPhone does, we suddenly just like simplify it to, it helps us connect with people. And the reason is there's just so much detail embodied within the phone itself that you just can't possibly communicate all of it in a single, you cannot possibly communicate it. So you're forced to simplify. So generally as well, I think when you're zooming out, you're forced to simplify because otherwise you'll just end up with a 500-page report.
Well, yeah, I mean, if you had to even explain, one frame of screen time in terms of bits flipping in the CPU, you'd be here for the rest of the time. That's it makes me think a lot about like the different abstractions that we need to put in place, and also naturally in the topic of AI, how we teach artificial intelligences or teach our models to have those layers of abstraction too, because I mean, we'll get into some of the details of saliency stuff a little later, but some of these topics about how people build models and build things, if they're looking pixel by pixel in an image, they might miss the larger ideas and, let alone in a collection of images or images over time, I think. Yeah, it's an interesting one.
Yeah.
For sure.
And let's keep talking about that, where it's how do we consider these different levels and these different zooms, both as the practitioner of AI and also for the models themselves. And I think this zooming out or this change in perspective helps you solve problems, helps with intelligence in 3 different ways. The first one is solving the right problem. The second one is keeping you on track and focused. And the third one is building connections that you wouldn't have otherwise seen. And we'll jump into each of those now. So the first one, solving the right problem. And I think this is like best described by something called yak shaving, even though it was not intended to be written that way. Or that feeling, and we'll link the article in the show notes. Or that feeling where you suddenly wake up and 2 hours, you wake up and you're still at your computer. You kind of wake up from your stupor, and 2 hours have gone, and you're 10 scripts deep, trying to like perfectly optimize the data set, and you're like, yeah, of course I need the GDP of Romania to the 10th decimal place. Of course I need that to make this model accurate. And then you're suddenly like, oh, hang on. Maybe I didn't need to be doing that. You might have been solving a problem and you might have been using tools to do it, but finding out the GDP of Romania was not exactly part of the brief. And I actually had that for preparing for this. I had that exact feeling for this. I was looking at the reference of a reference of a reference in a paper and trying to get a really, really, really good definition of zooming out and big picture thinking. And then I was like, wait, I think you could probably just have a go at this definition yourself, Tom. And it's not really the point. The point is to communicate to the audience this idea of changing perspective. They're not here to get some dictionary Merriam-Webster perfect definition of zooming out from a problem-solving context.
Yeah.
So it helps you solve the right problem.
Yeah. I think, one thing that I've noticed is I've worked with more and more people over the years is that one of the big transitions that happens going from like fresh out of engineering school to being more senior in the field is being able to do this, because you can spend all day optimizing your code or your report or your spreadsheet or whatever else. But I think it's when you gain that perspective of like how whatever you're doing fits into the bigger picture of the company or the project or whatever the hell you're doing, that you start to be able to make the trade-offs. Because I think in reality, we're all limited with finite resources and time and everything else, that if you're too focused on, shaving the yak, or I think bike shedding is the other one they talk about a lot, you're likely to miss deadlines and all sorts of other stuff. And at the end of the day, like, having a perfectly polished gear in an otherwise broken watch is not going to be very good at telling the time.
Exactly. Now, if I think about our three here, our solving the right problem, keeps you on track and focused, and building connections. I think if we had a scale of humans to AI as to who would be best to solve this, I think this is where humans are going to be far more successful until we've got general intelligence that wipes us out anyway. But humans are going to be the best at this rather than AI. The other thing on this as well is that I actually think this is how you begin to distinguish yourself in your career once you know the tools.
So, I mean, let's dive into, let's do the opposite. Let's zoom into both of those for a second. That comment about humans versus AI in this space, why do you think that? Tell me more. That's interesting.
Generally, so I believe that because data and information is very, very available. Compute is very, very available. Being able to direct those two combine those two to solve an infinite number of problems. Being able to determine which problem and which solution is the one that is going to satisfy what you need to be doing right now is something that only really you and or your team are able to do, because there are a number of different constraints and complexity that will not be included, and context that will not be included within the data and information available. Now, I think AI might be better if you gave it such a high level problem, such as how do we make the company more profitable, and then gave it the information to solve it. However, I think then you suddenly run into data and information constraints, as well as labeling and endpoints for the AI.
Interesting. It reminds me of this chapter from Nick Bostrom's book about. I think it was originally a blog post about the paperclip factory.
Yeah.
Which is like, your directive is to make more paperclips, and the lack of foresight or ability to do this from the paperclip factory AI means that it eventually turns the entire universe into paperclips. It feels very aligned with what you just said.
So I think one of the most famous examples of this is the planes that didn't return from World War II. And I'll link in the show notes, but it's called Bullet Holes and Biases by Abraham Wald, who was a mathematician. And during World War II, and it's kind of like the origin story of survivorship bias. And during World War II, a bunch of bombers were returning to the UK after doing their bombing run, and a bunch didn't. And what they did is they inspected where all the bullet holes were on the returning planes and started putting more and more armoring and reducing mitigating the risk of of being shot there, taking down the entire plane. Abraham Wald came along and said, whoa, you're asking the wrong question there. Instead of asking where are the planes that returned hit with bullets, he asked, where were the planes that didn't return hit with bullets? And he inferred that wherever there weren't bullets was actually where the armoring needed, because that was more deadly to the planes. And I think that's probably a really good, famous example of asking the right question.
Yeah, for sure. I remember seeing that the first time and thinking that was very clever.
Yeah.
Just that little jump of logic.
So number 2, it keeps you on track and focused. And generally as humans, in this kind of like entropic mimicking kind of way, we just generally default to more complexity and more detail. And as we add more detail, we find more and more problems. Sometimes those problems are tangential, and sometimes they are so low level that they won't actually affect the outcome of the situation. And a good example of that is trying to figure out the GDP of Romania into the 10th decimal point for your model.
I'm still waiting on that, by the way.
Yeah, I'll get to you tomorrow. This is, you've probably heard this come up colloquially as getting lost in the weeds, can't see the forest for the trees. And so that example there where you were just so distracted on a problem or issue that's come up that you've given yourself from the complexity that you've added to the situation. So zooming out will be like, whoa, hang on. Bit too deep there. Come back out. I had little business jargons for each of my 3 to describe the situation. I forgot to give you my business jargon for the first one.
Ooh, yeah. Come on, what's the business jargon?
For solving the right problem, the business jargon is fixing the deck chairs on the Titanic.
Mm-hmm.
Yep.
I have heard that one.
Yeah, probably from me. It's a favorite.
Maybe, yeah. Yeah, possibly. I think the other one was that I'd heard a lot is bike shedding. I don't know if you heard that term. It was like, I think it came from, I don't know if it's a real story, similar with the deck chairs on the Titanic.
I think people
it was
real cold. It was real cold outside. I don't think they had deck chairs on the Titanic.
Yeah, that's a reasonable point.
There were icebergs around.
But it was a group designing a nuclear power plant, a topic which we've touched on previously, funnily enough, and they had several meetings about what color the bike shed should be, as opposed to all of the many other things that the nuclear power plant needed to produce nuclear power, which could be why we may have forgotten how to make nuclear power. The link to that episode will be wherever links go. So yeah, check that one out.
All right, we're now really good at building bike sheds.
That's true. I mean, yeah, you know what? Take that, China. You might be the best at nuclear power plants, but show us your bike sheds, hey? They're probably pretty good at those too.
Yeah. And if we consider this with AI, to me, this is around like, how deep do you as a human have to go to build in your assumptions into the AI, into the models? And then also as well, how detailed do you want your data set?
Yeah, and also, like, I guess that thing of just because you can doesn't mean you should. Like, I think there's a lot of AI models that are probably very accurate, but, like, don't provide any real world utility. I see that all the time especially in the health space. Like, they'll solve this one little thing with health data and they'll think that they're going to save the world, but it's not really a health question. Like, it doesn't affect a real world health decision. So unfortunately, much like the Titanic, those are some very well affixed and maintained deck chairs on an otherwise sinking healthcare system.
Yeah. There's a saying in healthcare which is, does this help me cut or not cut? And to be able to produce something valuable in the healthcare space, you should be affecting that decision. And the cut or no cut refers to a surgeon as to whether someone should operate or not operate. And so that's a good rule of thumb of being always working towards that. And I'm sure every industry has something similar to that as well. So
yeah, for sure. Now tell me, what's business jargon for keeping us on track and focused?
Getting lost in the weeds. Can't see the forest for the trees.
Yeah, okay.
Got any
Very nature themed. Keeps you on track and
I
focused.
got another one.
Yeah.
Down in the trenches. Bit more
Down in the trenches, yeah. Yep.
I suppose that one's a bit more...
Keeping our eye on the ball.
Mm-hmm.
People say they want to double click on stuff a lot, which is a funny expression. I guess that's similar. I don't know. I can't think of any more on that one.
Yeah.
We'll circle back after.
I heard double tap the other day.
Double tap?
iPhones are... Yeah.
Holy moly.
Business jargon is upgraded to touchscreens.
Yeah, when we get our VR headsets, it'll be whatever this motion ends up being.
It doesn't... Oh no, double tap means something quite... Yeah. Look up that bit.
Moving on.
The third thing is... Can Jimmy Bob just get us on your little keyboard there, just a moving on button that just comes right over the top with a foghorn. Moving on.
No, it's all staying in.
Okay.
It's too time consuming.
Third one is building connections that you otherwise wouldn't have seen. If we just quote Mr. Jobs himself from his speech, he goes, it's like that you're in a city and you can see the whole thing from the 80th floor down at the city while other people are trying to figure out how to get from point A to point B, reading these stupid little maps. You could just see it all out in front of you. You could see the whole thing and you could make connections that just seem obvious because you can see the whole thing.
That feels a lot like seeing forests from trees.
Yeah.
What do you reckon the difference is between these two?
To me, the first one is you're actually just you're too busy staring at the tree. And this is...
Oh, okay.
This next one is that you take 10 steps back and you see that there's a axe next to the tree that will help you cut it down, and you make that connection.
Okay. Yeah, fair enough.
Yeah.
Lumberjacking. I like it.
Yeah. So, and this one kind of cuts into a little bit on another form of reframing, which is considering problems from a different angle. So if we go into our business jargon for this one, it's attack from another angle and things like that. So this is all about this kind of thing. I think the zooming out helps you with that time when you realize, oh, this problem reminds me of this, or maybe if we thought about it this way. So this is my third reason as to why zooming out helps.
Yeah, cool.
A good example of that is something called Dunker's candle problem. We've talked about this before, but
I think we have.
And I've forgotten the name of the psychological term for it, but it's the idea of getting over something's, moving past something's core normal usage and seeing a hammer as something that isn't a hammer, for example. Seeing it as a paperweight or something like that. In the Dunker's candle problem, the participants are given a box of thumbtacks and a candle, and they're told that they need to stick the candle to the wall. And people stuff around trying to stick a thumbtack through the candle, and it breaks the candle and it doesn't stick, blah, 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 blah. But the insight that you need to realize is that the box that the tacks are in are actually part of the tools that you are given. And the goal is to stick the box to the wall, and then you put the candle on top of it. And
Which just seems like an absolute recipe for a fire. But
yeah, hey, it was done in the 50s.
Dun-
It was done in the 50s. They did some
Yeah.
crazy thing in the 50s.
Dunker tragically died when his lab burnt down, but
Yeah.
up until that point, he was very well respected.
So the idea of this third point is like seeing the connection that the box is actually a tool rather than just something that stops you stabbing yourself with the tacks.
Some might say not getting dunkered down in the details.
Yeah, let's go with that. So those are kind of the three things that I think help with problem solving. But I think there's one thing as well that a lot of people don't mention a lot, which is actually it's the change in perspective from the low to the high that is the valuable, from the detail to the bigger picture. Zooming out, I think it's that change in perspective that is important, not actually just sitting there at the high level the entire time. So to keep Steve Jobs' example going on, I think you need to regularly go to the ground floor and the 80th floor. And I had one of my mentors describe this as porpoising, where, you know, dolphins, where they jump in the water and they play and they like jump in and out, they jump in and out, they're underwater, out of water. And the reason is if you're too far down in the detail, you're never going to figure out whether you're working on the right problems, and you could suffer all these traps that we've talked about. But if you're too high level, you're never going to actually do any work, and you're never going to come to anything insightful or deep. So the important thing is to be changing that perspective, to porpoise in and out, zoom in, out, 80th floor, ground floor.
Yeah, good. The high dynamic range for those nerdy engineers in the audience. I like it.
So kind of what does this mean for you as an individual for you, Elliot? Exactly you. What does this mean for you,
specifically?
Elliot? Is that there's kind of two things. One is that I think that you need to remind yourself that you need to play at different levels. You need to consistently, and I think especially if you're early in your career, the easy thing is to go deeper rather than come back out and find yourself deeper into the problem, into more complexity. So, and I found this for myself as well. I always needed to pull myself out and make sure that I was coming up for a bit of fresher breath air at the 80th floor every now and again. And like, look, there's higher and lower levels within the work that we all do, right? Like, I'm not sitting there at my first job. As your first job, you're probably not sitting there if you're working for Google asking the big question of what should Google be in 10 years. That's probably a bit too high level for you at that stage if you're just a graduate. But within all of our work, there are higher and lower levels of questions and work that can be done. And your job is to remind yourself to keep coming back up to whatever your 80th floor is. So, for example, if you were just a doctor, that would be, rather than fixing the actual problem in front of you, asking the question about the actual health of that patient in front of you at that time. If you're a developer, that would be the purpose of the section of whatever you're working on at that time. Making sure that whatever you're doing is actually solving that problem that section is intended to do. So keep coming back up for air and keep the question top of mind. I used to sticky note it on my laptop as well, of like, what is the problem that I'm solving?
We do worry about Tom's short-term memory sometimes.
Yeah. And then the second thing as well is make sure your team is playing at different levels as well. Now, I kind of imagine this as this stacking system as you go all the way from the bottom to the top of like everyone's floors are overlapping and together you build a big building, and the CEO is at the top looking at has to go to the highest floor, and the graduates down the bottom have to go to the lowest floor. But what that means you've got coverage across the entire problem if you're all working like that. But it also means that you've got people both above you and below you that need to be doing this as well, doing the zooming out. So if there's people below you, you probably have a reason. You probably have a part of your job description to be coaching them. And this is one very simple thing, and it's very simple to do it, is just ask them the question of, is this solving the actual problem? And keep them on that. And keep them coming up for air. But also as well, I think it's important to manage upwards in this point as well. So if you have a manager or a boss, make sure that they are asking the questions above you that need to be asked. Make sure that they're going to their 80th floor. If you're starting to feel a little bit micromanaged, you're starting to feel like they are defaulting to more on the tools than you'd like, it's probably a symptom that they're not going up for air to check they're not going up to the 80th floor. So remember to help. So that is, play at different levels to yourself, and then make sure your team is playing at different levels. I think those are the two things to take from this.
I think that's good advice. Yeah, nice one. Well, thanks, Steve Jobs, for that little bit of wisdom in the early 80s.
When he still had hair. That's how old it is.
Sounds like a smart dude. I wonder what he got up to since then. Guess we'll never know. We will never know. This week's episode is brought to you by Apple. It's not a wish. Imagine that. I'm sure the CPM on an Apple sponsorship's pretty decent.
It might have paid for all the equipment that we've purchased to record.
Yeah, there you go. By this Apple Pencil. Anyway. Good stuff.
We can only wish. Shall we take a break?
We can only wish.
Get a Kit
Yes,
Kat.
we will take a short break. I wish I had a Kit Kat, and we'll be back for topic number 2 very soon.
Your turn.
A couple of topics from me this week. Some stuff I had on my reading list for a while, and there's some stuff that's just come out. So, very high level. Read an article from this publication called Nautilus talking about a lot of these big models like GPT, DALL-E, whatever, and whether or not they just repeat stuff from their training set, and why that might be bad, how we can assess whether that's true. And that brought me to a more recent article. I think even that's probably not actually that recent anymore.
Double Article Wednesday. Love it.
Anyway,
Controversial.
Double Article Wednesday. Yeah, from Lauren Ogden-Rayner, someone who I've spent a little bit of time talking with in the past, radiologist in South Australia.
Is that a sneaky AI flex?
I don't know, she's pretty cool. Maybe she'll come on the show one time. About some work that she published with some of her colleagues around training a model to explain some of its decisions in classifying fractures in X-ray images. So mash those two together in the vague semblance of a podcast conversation.
Okay. So what do you want us to walk away with by mashing these two together? What questions do you want us to walk away with, or what answers do you want us to walk away with today?
Yeah, it's a good question. So I just read this stuff because it's interesting, and I like to read a lot of different stuff on AI, as you might have guessed. But I think the two pieces that I put together here comes kind of back to what we were just talking about around intelligence. Is how do we know when these AI models are really intelligent and really doing stuff that is novel and interesting and shows some form of intelligence? Put aside the question of sentience and stuff. We talked about that. I don't know where the things go, so I'm just going to point in both sides in a different episode. I'll probably forget to put them up too, so I'll just be pointing it anyway, whatever. How do we know when there's intelligence there versus just regurgitating? And there's this concept from it's from a paper, but they talk about it in this Nautilus article, which is these stochastic parrots, which is basically you train the parrot to just repeat human voice sounding stuff on command, and you think, oh wow, the parrot understands language, but it's no, it just knows when to respond.
Are there any good examples of stochastic
ways.
parrots that have been published and then pulled or anything like that?
I don't know if there's been any big ones that people didn't realize until too late, but if you train a model yourself, or train some of these earlier sort of precursor language models, like these Markov chain models, they're pretty easy to be kind of convincing, and then you can get them to fall into traps where they just start repeating the same sentence over and over and over and over again.
Yeah.
This article puts forward this other term called stochastic chameleons, which is that, it's not really a memorization and regurgitation. It's that these systems, whether it's GPT-3 or DALL-E or whatever, they're really good at adapting to their local environment and working in that context. So, they can start talking about pictures of bears riding unicycles on the moon in the style of Claude Monet. Now, the training set almost certainly didn't have that in it, but because these models can be chameleons, they can blend in. And the article says, maybe that's, and that's particularly where we have to be careful, because, we might think a chatbot is sentient because it's been trained to blend in and answer questions about sentience in a very convincing way.
Is this one of the accusations of Lambda, the sentience of Lambda that we discussed in episode something or other?
You just got to point up, man. YouTube will just magically do it.
Yeah. Episode 11.
Oh, there you go. That saves me having to look it up when I have to link it. Yeah. I mean, it's a similar thing. It's like, does this chatbot is not regurgitating stuff it's heard before, because it's never had these exact conversations before, but it is very good at trying to blend in with a set of context, and it's probably read conversations about sentience and intelligence and things, and so it can do a passable job of existing in that environment, even though, much like the chameleon or the squid or anything else, that the parts of their body that make those adaptations, it's not as much a conscious choice as it is a sort of evolutionary adaptation to survive or blend in or hit some metric in this case.
Yeah, I have a lot of questions, but what is coming to mind is, that person that you've all worked with that just says, that regurgitates buzzwords and just says things. These models remind me of that person where they probably thought of those things themselves, but then they said it and it didn't really mean anything, and it kind of fit a formula of regurgitation.
Yeah, 100%. And that is actually a spot-on example of, that one person who's, fresh out of whatever degree they did. Maybe let's just use a self-deprecating example. Probably us at some point.
Yeah.
Just talking about different AI models and all this sort of stuff without really knowing what's going on. But we've heard the term convolutional neural network before, so it's definitely one of those.
It reminds me of like when someone says, we use AI and machine learning, and it's like, don't you just like process food orders and then aren't you a McDonald's?
Yeah. There's like 8 if statements, and then they've got an AI model. It's and that is a spot on example, I think, of what a stochastic intern, let's call them.
The other thing then is that, like, to me, a stochastic parrot versus a stochastic chameleon. Like, the chameleon is still a development from the stochastic parrot. It's still a step forward because it's still able to, as you said, make choices within certain situations, but it blends in when it's failing to make sentient choices.
Yeah, but I think the point that these, and it's a hard example, but because we're going from a parrot that's speaking to a chameleon that's changing its colors, but I think the point here is that, like, the chameleon can be in a tree and be brown to be a stick, or it can be on a blue car and be blue, but it's neither a stick nor a car. It does a good job of, like, blending in with its environment, but at the end of the day, it's still a chameleon. It's still a lizard. It's not a car. And I think this is the point that we're getting to, is like, we're getting mimicry, good mimicry, but it's still not real.
At what point is good mimicry good enough?
Well, yeah, I mean, it's is it Asimov who said, probably not. There's probably some sci-fi people that are going to murder me if I get that wrong. But the advanced enough technology is indistinguishable from magic. I think, it's very similar in this case. It's like, once you've really got to ask, like, if we can be a stochastic intern, just like a stochastic chameleon, like, are humans really doing something different here, or do we just know how to do this at another level? So I don't know. I mean, number one, again, as with all of these discussions, we just need better definitions. Like no one defines intelligence or sentience or any of this sort of stuff before they start arguing. And so it's all very meta.
And we're going to solve it here today. We're going to solve sentience and intelligence. You heard it here.
Yeah, welcome to our first 16-hour episode of high output AI. This is what the high output means, folks. The length of the episodes is long.
Yeah. It's nothing to do with what you'll get from this.
Yeah, no. It's this is the 80,000 foot view, but described at the atomic level. Anyway, enough really high quality bands. So this brought me onto another article from Lauren. Ogden Rayner. I always feel like I'm mispronouncing that. I'm pretty sure I'm not. Ogden Rayner. No, easy. I don't know why I worry about that so much. Anyway, so she's done this work. She's a radiologist at I don't know what the actual name of the institute is called. It's in South Australia. It's like a machine learning institute that works a lot in medicine. She's trained as a radiologist. And she does a lot of work sort of criticizing shortcomings in data bias and ethical applications of AI and so on. And this is some of her work looking at...
Warranted criticism, right?
Oh, yeah, 100%. 100%. Like, it's a huge problem, and especially in high-risk fields like medicine, you don't want to fuck this up. You don't want your model to be a stochastic, squid. If the thing that it's mimicking is, should we cut, as we said before. So this work is taking a image classifying type setup that looks at X-ray images and trying to not only create a useful label for it, so like, is there a fracture, yes or no, but also describe the nature of the problem in a very reduced vocabulary. So I don't know how many of our watchers or listeners have read radiology reports, but they're very verbose and they're not very standardized. So part of this work was to, get a very limited vocabulary version of the problems and use that as a way to convince the radiologist receiving the output of this AI that not only was it correct, but that it made some sort of logical sense. Sorry, I thought the dog was going to go crazy.
Hang on, let me jump in.
Somebody slammed the door outside.
Let me jump in with the question. So, explainability all comes down to a number of different metrics, right? And there's a couple of standard ones. There's calibrations, there's soundsy maps, and there's a few other things in there as well. Can you give us a quick definition of like how you generally would consider setting up explainability, and also picking the right metrics to picking the right... Midas has joined us on screen. He's going to explain soundsy maps to us.
Yes.
Yep. You've got the question.
Yeah. So, there are a lot of different ways that people have tried to do explainability, and it's really hard. And I should say that, like, it's really hard for people to do it too. There's been a lot of tests where people have had to explain why they do stuff, and like a lot of it ends up being post-justification. We've probably talked about this like 500 times between us, and probably several on the show. But there's this experiment where patients in a treatment for epilepsy had the left and right hemisphere of their brain separated, and the sort of center for language processing is on one hemisphere of the brain, and the research study put a dividing line between the eyes of the subject, and because each side of vision is processed by a different half, one side had a few different random objects and the other had a sign which said pick up the can of Coke, and they did. And then when asked why they picked it up, they said, I was thirsty. And the reason for that is that the sort of reasoning parts of their brain were not connected to the language center. So despite the researchers showing them a sign which said, pick up the can of Coke, they sort of post-justified their explanation as, well, I was thirsty.
So we're bad at explaining to ourselves, but is there a couple of core metrics that will generally, obviously not, I don't believe in one metric providing the answer for everything, but is there a couple of core metrics that can help us cut through our own biases and help explain these models?
Yeah, so there's a few that people have tried. Let me put it that way. So one of the big ones is saliency, and I'll put it in the show notes. I supervise a couple of PhD students. One of them, their whole thesis is on saliency methods in medical applications, and she recently published some work at a conference here on the Gold Coast around looking at, I think it was 4 or 5 different saliency models on the same data set on the same model, and seeing and noticing that the different methods of explanation provided very different explanations for the exact same output. So, all of these models would say it was a dog, but you'd get 6 different reasons why it was a dog. So let's just caveat with that. These are far from perfect. There's also like feature visualization, which is, I guess, somewhat like image generation, which another PhD student I supervise is working on, which is, okay, you're saying that it is a wrist fracture. Can you generate, 5 or 6 other wrist fractures just so I can make sure that you really understand broadly what a wrist fracture is? There's more traditional statistical ones like calibration and sort of simplicity and clustering, which is similarity, I should say, not simplicity, which is like, okay, I think this is a case of prostate cancer, and here's 6 other ones that got a similar score, so that you as the reviewer can see that I have a pretty consistent image of what cancer is, and that's kind of similar to the feature one.
So there's a number of different ones, but none of them are perfect, and it seems like they can also fail to be repeatable.
Yeah, 100%. But one of the interesting things Yeah. I mean, what do they say? Like, all models are shit, some are useful, which I find to be the most annoying statement. Because the people I've heard use it to justify why everyone else's models are shit, but why their own models are useful.
The actual saying is like, all models are wrong. It's just how wrong.
Yeah. But anyway. Some of the examples in here, throughout the work were about, say, a radiologist making a typo about, what region of the body they were looking at, left or right, things like that. And then the reader saying, oh, I know what they meant, which I think was an interesting thing. And I'm sure it happens. And I'm sure it's true that, if they make a logically inconsistent statement, that the doctor can be like, hey, did you mean this? And they say, yes, that's actually what I meant. I don't know if we'd give the same leniency to an AI model, where if it said something like, this x-ray of the hand has 3 broken toes, and we said, oh, it must mean fingers. And if we went back to the AI and said, did you mean fingers? And it said yes, like, would we buy that? But I don't know. I mean, humans seem to have a lower bar in some regards, but a big part of this work, I think, was trying to find multiple angles, especially in the text generation, multiple angles of consistency in what the thing was seeing. And what it looked at was location, so where the problem was, some descriptions of the type of problem, and the severity of the problem was sort of the 3 factors. And if it could generate, the correct location, the correct type of problem, and the correct severity, that gave the reader multiple reasons to believe the ultimate outcome, which is cut or don't cut.
And did it perform better on any one of the 3 consistently, or was one letting it down?
So it seemed to perform really well on location. It didn't do quite as well on some of the others, but it was still really, really good. And There was a couple of experiments done. One was on the original full radiology report, which it wasn't great at because of inconsistencies. When it was on the reduced vocabulary, so the sort of simplified radiology reports, it did really, really well. And I guess I should define what really, really well means and how this was assessed. So it was two ways. One was this metric called BLEU, which is looking at, do the words that I care about appear in the output? It's a metric. It's not great. And I'll give you an example of why it's not great. Let's say you're generating a image captioner that's looking for different farm animals, and you want it to say cow when there's cow. And so you put that in your target set. If the caption generated is, this is definitely not a cow, but you were looking for cow and it sees cow, it'll give it full marks. Yeah. So anyway, the other one was a much more, I shouldn't say more robust. It was a different assessment, but it was having humans compare the accuracy of the output, so the generated short radiology report, to what they knew was wrong. So they did that for both the original human reports, and then the ones produced by AI. And
was that blinded,
really well
or did people know they were reviewing AI or doctor?
It was blinded.
Okay,
it was blinded. So it was quite cool. I mean, it was 5 different doctors with different levels of experience, between 3 and 7 years of sort of postgrad experience, looking through the reports, and they all had experience in the space, which was quite good. It's good to see that, because otherwise people just throw things up like these BLEU numbers, and they don't really mean anything in the real world.
And so how did it perform on these two?
So in this particular example, which Lauren points out is one use case on one data set from one place, it got like high 90s of accuracy. It was rated very highly. Interestingly, so there was another experiment in there, which was, do the radiologists want the saliency maps, the verbal descriptions, or both? And how do they rate those 3 scenarios in terms of accuracy? Saliency was like an average 4 out of 10. The text description was an average 6 or 7 out of 10. And then the saliency and the text got it up to like an 8.5 out of 10. In terms of, how well does this help you assess this and how accurate is it? I find that kind of interesting, because I've noticed this bias, and it's fairly well documented, in that if you present people with, I guess, more little widgets on their dashboard, they'll almost always pick show me all the widgets. And this is true in medicine as well. Diagnostic tests very rarely replace another diagnostic test. They're usually used as an adjunct or an addition. And that can get quite expensive and quite overwhelming pretty quickly. You can imagine if, the clinicians were offered more explainability markers, eventually they'd have a screen full of, 200 different markers, and they'd be scratching their heads saying, like, what the hell does all this mean? You get alert blindness, I guess, was another term.
Metrics to explain the metrics.
Yeah, exactly.
Okay, so I'm cheating, and I've got your notes here. Talk to me about moonwalking with Einstein.
Yeah, so this was something that I sort of clicked with me as Lauren was talking about spatial reasoning and object or event reasoning being processed by different parts of the brain. So there's this book written by, I think it was an Australian journalist, that was looking into like world memory championships. And there's this well-known memorization technique called memory palace, which is all about taking what you want to remember. Maybe it's a deck of cards, or maybe it's numbers, or things like that, and encoding that information in weird events. So Einstein doing a moonwalk, placed in a series along this sort of virtual or in your brain exploration of a space.
Yeah, I've had it explained to me as you pick your family home that you remember really well, and you walk in the front door, and the first item you want to remember is hanging on the front door, and it's really weird. And then you turn and you hang up your coat, and the second item's there, and then you walk in my particular home that I remember, the lounge is on the right, and so that's the third item, and then you walk through the dining room and the item's in there. And I do this is how I remember speeches. And I remember one is that in my lounge room I imagined a bunch of radiologists looking at MRIs after MRI after MRI, and the room was just full of MRI and doctors looking at it, and it was to trigger me to remember that MRIs are exploding and imaging is exploding in growth, and radiologists aren't able to keep up over the next 10 years, and this is why we need AI.
There you go. I mean, this is a tangent, but I've never been able to get it to work because I haven't really tried. It's on my list of things to like try and do one day, is memorize decks of cards and random shit like that. But I lived in a lot of houses growing up, like a lot.
Yeah.
And I don't think there's any that I really remember that well.
You should do like your PhD room.
Yeah, true. I mean, I'm sure I can make it work, but
Elliot
anyway.
is mind homeless.
yeah, exactly. My memory slum. No, we just moved around a lot for perfectly happy family reasons, not weird, running from the law or anything like that.
Moving on.
But yeah, it made me think that about different processing centers in the brain, and how if we could convince more than one processing center, we're more likely to trust what we see from the AI. Which also made me think, how much of this work around building AI that is intelligent or sentient or whatever else is really a bias towards the way our brains work. So if we didn't have this sort of spatial center in our brain separate from the language center, separate from events or memory or anything else, would our Turing test, for lack of a better word, look really different? And how would an alien civilization determine if we were intelligent if their brains are all mushed together in a very different way?
So let me repeat this back to you. The question that you're asking is, what biases cause biases in our AI and machine learning?
Yeah, and so it's almost a translation problem.
Or what lack of ability / intelligence by us causes us to not trust or to not accept AI.
Yeah, it's more around when we get to that threshold of is the AI, sentient, to keep coming back to it. But you could ask the same question of the saying used to be that if you could talk to a lion, you'd still have no idea about its world. If a lion could speak English, it's just its day to day, its existence is so different from ours that you just wouldn't be able to relate. Which I don't know if that's true. But let's just pause here for 1 second because I am about to have a guest. Maybe. Someone's here. It's Elle. She's home.
I'm home. Yeah, she's coming home. Alrighty, let's take a practical when we do go back.
Yep, that sounds good. We're pretty much coming up on time too, so we don't need to dwell on this too much longer.
I want to dwell on it all day.
Dwell. Yeah, good. All right, let's just get back into it. All right, we're back. I said we're back.
Hang on, I was ready. I forgot my question.
Oh, good. Yeah, well, you have 30 seconds to come up with your question because we're coming up to time and we got to wrap this one up.
So what does this mean for someone who's in the middle of creating AI or ML to help in a space like this where explainability is a very important property? What can they be thinking about before they even start? What can they be thinking about during, and or if it's already done, what should they be doing to look back on the situation and determine whether they were a stochastic parrot? And then also your final question, what is your stochastic spirit animal?
I like that one. I think number one is like what I really loved about this work from Lauren and her team is that they took quite a novel approach to explainability, and that was to, I guess, layer on different dimensions of explainability to sort of justify how it was making its decision, which I think is a very human-centric thing to do. And it goes beyond a lot of the, here are the bits in my text that I signaled as most important in quite an interesting way. So I would say if you're working on an AI project, looking into explainability, try and, I guess, think around how you might be able to do it in a different way. I think what was interesting here is that radiology reports are typically text, so it could be done that way quite naturally. But that was quite cool.
It seems to me that, sorry to ask you the question then to answer it, but it seems to me that like step one is actually think about explainability, and then step two is think about multiple ways about explainability, because one isn't an answer.
Yeah, definitely. And I mean, also, I guess back to our Steve Jobs-esque type entry point to this today, take the zoomed out view and actually determine whether explainability is needed. There are a lot of AI problems where explainability would be overkill.
Can you give a few examples?
Like if you're building a search engine that's going to return, 10,000 results for a search term, explaining exactly why you picked every one of those results is just not a useful addition of time. It's really only if somebody's going to interrogate the output of whatever you've done, that's when explainability is handy.
So it's almost like when the stakes are a bit higher.
Yeah. That's a good way to think about it. Like, if the decision is cut or don't cut, then explainability is good. If the decision is like, is this a funny meme? It probably doesn't matter. And my stochastic spirit animal would probably be a porpoise, in line with our previous discussion, because I think, one of my historical flaws has been to stochastically move from the ground level to the 80,000 foot view, much to the dismay of my productivity. What about you? What is your stochastic spirit animal?
I'm trying to think of something funny and witty, but someone once described me as an unpotty trained labradoodle, so I'll just go with that.
Okay, and I mean, what's the stochastic part there? Given that you said unpotty trained, is it that you just like shit randomly?
Yeah, sure.
That seems real dangerous. Man.
Yeah, I just get so excited I wee myself. I do.
Yeah, fair
in
enough.
real life, I get so excited, but I don't wee myself that often anymore.
Lots of caveats on that one. Yeah, good. Well, I mean, that seems
Never say never.
No, yeah, fair enough. I mean, I guess life is really just, drifting between 2 5-year periods of pissing ourselves, isn't it? One at the start, one at the end. If we're lucky enough to live that long. That's some wisdom.
And on those, that happy note, shall we call it? Anything to plug this week, mate? Or
anything to plug this week? No, I've been reading some good books and things, but I'll plug those once I get through them in case they suck at the end. I would just say, if you enjoyed this, subscribe, like. If you're listening to this in audio, keep listening. I don't know if there's the similar metrics there, but tell your friends because we're having fun. And if there's anything you want us to talk about, drop it in the comments down below. What about you? Anything to plug?
I'll just plug ourselves and just say we're producing stuff on AI, producing stuff on problem solving, and welcome to the new show.
Welcome to the future. All right, friends. Until next time.
Bye-bye.
Bye-bye.